So, hi students, and welcome all on Yourpedia Education platform. And today we have a class of fluid mechanics for HAL students. So generally this is the combined class for any PSU. There is a NHPC, All India Limited and Bharat Dynamics Limited. So we already launched the module and which is valid for all the exams. Okay? So those students who are interested to purchase this module, so they can contact in the video. I will share the description. So today let's proceed with the fluid mechanics portion. So earlier this is the lecture number 3. Okay? Earlier we complete 2 lectures. So this is the lecture number 3. So let's proceed with the question. Okay, so here's the first question, guys. So this is the first question. So the pressure inside a soap bubble of 50 mm diameter is 25 Newton per meter square. Above the atmospheric pressure, the surface tension in the soap film would be. Okay? So earlier I already told to you guys the boundary layer and the fluid machinery, just like a pump turbine. That topic I left, that is covered by the separately. Okay, as I discussed with you guys. So today we are just confirming all the chapters and having the questions from these chapters. So okay, so in question the pressure inside a soap bubble of 50 mm diameter is this one. So this pressure is above the atmospheric pressure. So simply excess pressure is given to us. This is the 25 Newton per meter square, because in question he wrote here above atmospheric pressure. So this is your excess pressure basically. Fine. And the surface tension in the soap film. Surface tension in the soap film, the formula you know very well. This excess pressure delta P is nothing but 8 sigma by D. Okay, 8 sigma by D, where sigma is the surface tension, D is the diameter of the soap bubble. This diameter is given in the question. This is 50 mm. Okay, so we have to calculate this sigma surface tension. This excess pressure is given as 25 Newton per mm square. So let me know what is the answer basically. So 25 equals to 8 sigma, diameter is in mm. So have a look on the figure, and this excess pressure is in Newton per meter square. So convert it into meter. So 50 into 10 raised power minus 3. So this will also be in the meter. So sigma, just do the calculation guys and let me know the answer. So 25 into 50 into 10 raised power minus 3 divided by 8. So let me know the answer. Let me know the answer. So just solve it. Okay, the answer is coming to be 0.1562. So I solved it. So this is coming to be 0.1562 Newton meter. Fine. Newton per meter. This is surface tension. Na? Why Newton meter? Newton per meter. 0.312. So just check the calculation part. Ritesh, check your calculation part. So okay, so 25 into 50 divided by 8,000. Yes, it is coming to be 0.156. I don't know why this is 0.312. Answer is coming to be option A. Option A is the answer. Fine. So just have a look on the calculation part. Yes, option A will be the answer. Fine. So let's proceed to the next question. So next question, when the pressure on a given mass of liquid is increased from 3 megapascal to 3.5 megapascal, pressure is increased from the 3 to 3.5, the density of the liquid increases from 50 kg per cubic meter to 500 kg per cubic meter to 501 kg per cubic meter. So there is a change in density, change in pressure. What is the average value of the bulk modulus of the liquid over the given pressure range? So we have to find here the value of the bulk modulus. Okay, so how can we write the value of the bulk modulus? So let us see. So generally this bulk modulus is denoted by K. So this is your change in pressure with respect to the rate of change of density. So this is d rho by rho. Fine. This formula we have generally. So in numerator we have the change in pressure value. So we can write it like this one, rho into dp upon d rho. So what is the change in pressure? So in quotient it is written as pressure is from 3.5 to 3 increased. So 3 to 3.5, what will be the change? Of course it will be the 0.5 MPa, right? And density is increasing from 500 to 501 kg per cubic meter. So change in density will be 501 minus 500. So definitely it will be 1 kg per cubic meter. Fine. So just catch the value. Density is this density is 500, right? So 500 into this change in pressure is 0.5. Fine. This is in Newton per mm square. So kind of megapascal upon this value unit is kg per cubic meter, and here we have 1 again kg per cubic meter. So kg per cubic meter cancel out. Just do the calculation and let me know. It is coming to be 250 MPa. 250 MPa. So option D will be the answer. Option D will be the answer. Have a look on this one, guys. Is it okay or not? Option D will be the answer. Fine. Option D will be the answer. Clear? So is it okay? Okay. So let's proceed further. Okay. Here the next question. The equation of a velocity distribution over a plate is given by u equal to 2y minus y square, where u is the velocity in MPS at a point y meter from the plate measured perpendicularly. Assume this dynamic viscosity is given to us in poise, 8.6 poise, and shear stress at a point, he's asking about the shear stress at a point 15 centimeter from the boundary is. What is the shear stress at a point 15 centimeter from the boundary? That is the question basically. Okay, so let's solve this question. So this velocity is given to us. This is 2y minus y square. This equation is given to us in the question, and we know very well this rate of change of velocity with respect to this distance from the plate, or du upon dy. This is kind of your velocity gradient. This you know very well. This is your velocity gradient or rate of shear strain. Velocity gradient. So how can you write it? Velocity gradient. This is the derivative of u with respect to y. So it is coming to be 2 minus 2y. Fine. 2 minus 2y, and in question du upon dy, that is kind of velocity gradient. Let me go to the question part. So he's asking basically y meter from the plate measured perpendicularly, assume this one, and the shear stress at a distance 15 centimeter. Shear stress at a distance 15 centimeter. So put y equals to 15 centimeter, that is 0.15 meter. So let us check what will be the velocity gradient or rate of shear strain. So just put the value 2 minus 2 into 0.15. So this is coming to be 2 minus 0.3 and 1.7. 1.7 we are getting here velocity gradient. Okay, and this dynamic viscosity is given to us 8.6 poise. So just divide it by 10. So we are getting it 0.86 pascal second. Fine. So we convert it value in SI unit. Just sketch the figures and let me know what is the answer basically. Okay, so he's asking about the shear stress. So tau equal to what? Mu dynamic viscosity, and du upon dy, du upon dy. So this is 0.86 into 1.7. Just solve this one and you will get the answer. So let me solve this value. Okay, this is coming to be This is coming to be 1.462. 1.462. 1.462. So let us see what will be the answer. Option B, 1.462. Very good. Option B will be the answer. Fine. Option B will be the answer, 1.462 Newton per meter square. Right? Option B. You can see. Although 14.62 is there. So don't get confused. So do the calculation carefully. So next question. So in next question, the shear stress developed in a lubricating oil of viscosity, again in poise. Whenever the term viscosity is saying simple viscosity, so dynamic viscosity, this one, this is given to us 9.81 poise. So to convert it into SI value, so just divide it by 10. So we will get here 0.981 Pascal second, meaning to say that Newton per meter square into second, Pascal second. Fine. So filled between the two parallel plates are separated by 1 centimeter distance, moving with the relative velocity of this one. Okay. So velocity of one plate with respect to another plate is 2 meter per second. So let me draw here the figure. So suppose here is the plate number 1. This is a plate number 1, and this is a plate number 2. Fine. So these plates are separated by a distance which is given to us 1 centimeter, and the relative motion or movement of this plate is given to us 2 meter per second. Fine. And the fluid which is in between these two parallel plates having the dynamic viscosity 0.981. Let me check. Yes, 0.981 Pascal second. Pascal a second. So right now we have to just apply here Newton's law of viscosity formula for calculation of this shear stress. So tau equal to mu du upon dy. This you know very well. The basic formula. This mu is nothing but 0.981 given in the question. We just convert it into the SI value. So du is the change in velocity, dy is the change in distance basically. So as we move this plate away from the plate in the upward direction, what is happening here? The velocity is increasing. Suppose we have only one plate here. This is a plate. So there will be the change in velocity. There will be the change in velocity with respect to this y distance. That is change in the distance from the plate axis. So generally it's du upon dy. Du upon dy. Du is given directly to us 2 meter per second. This dy, what is the distance here? 1 centimeter. So let's convert it into meter. So we know very well 1 meter equivalent to what? 100 centimeters. This is coming to be 1 by 100. So 1 by 10 square meter. Okay. 1 centimeter. So it is coming to be 1 by 100. So this is coming to be 10 raised power minus 2. Fine. So this we got here. So let me know, just solve it, and what is the answer coming to be. So this is coming to be generally 2 1s are 2, 2 8s are 16, 2 9s are 18 and 19. So 1 2 3, so 19.62, right? 19.62. Just check the answer. Is it okay or not? I think we did some mistake. I think so. So this is 981 divided by 1000 into 100. ठीक है, ओके 196.2 आ रहा है, वेरी सॉरी 196.2 आ रहा है कि नहीं? जस्ट हैव अ लुक ऑन द कैलकुलेशन. दिस इज कमिंग टू बी 196.2. 196.2. only 10 we are getting in the denominator, so answer will be 196.2. fine, is it okay? 196.2. okay, good. चलिए, so here's the next question. The pressure at a point in a water column is, ठीक है, pressure at a point in water column is 3.924 Newton per centimeter square. So pressure is given to us. Pressure is given to us. What is the corresponding height of water? What is the corresponding height of water? ठीक है, so pressure is given to us 3.924. So he's asking about the height of water. So pressure is given to us 3.924. This is Newton per centimeter square. Check again. 3.924 Newton what per centimeter square. Is it okay? So just convert the value into Newton per meter square. So we know very well in 1 meter we have 100 centimeter. So 1 centimeter we have 1 by 100 meter. So 1 centimeter square we have 1 by 10 raised power 4 meter square. So this is coming to be what? So 3.924 into 10 raised power 4 Newton per meter square. That we got here. We change this one. Okay, we put it in the meter square, although the thing was given in the Newton per centimeter square. So pressure we know very well, pressure equal to rho g into h. Fine. He is asking about the height of this column. So pressure is 3.924 into 10 raised power 4. Okay, rho g. What will be the rho? What will the g? In question, he clearly mentioned the water column. Water column, density of water, you know very well, density of water is 1000 kg per cubic meter, and g, gravitational acceleration value, that is 9.81 meter per second square. So in general, rho into g. If we multiply this mass density or density with this acceleration due to gravity, what we are getting here? Unit weight. But we are getting here weight density, whatever you want to call it. Fine. So this rho into g, I am writing it combinedly 9.81. This is in kilonewton. Okay. So multiplying it by 1000. So this is in Newton per cubic meter. This thing h is here, and here we have Newton per meter square. Fine. Newton per meter square cancel out. Only meter will be here. Meter here multiplied. So let me know what is the h here. So 3.925 into 10 to the power 4 divided by 9.81. So 10 to the power 4 times power 3. Just solve it like this one. 3.924 into 10 raised power only 1. So 9.81 generally. Okay, 10 to the power 3, 10 to the power 3 will cancel out each other. So this is coming to be 39.24 divided by the 10. So 9.81, let it be 10. Okay, so 3.9 will be the answer. 3.9 will be the, in general way. I'm just doing the in faster way. What will the answer? 3.9. 3.9, it is very close to 4. Option C will be the answer. If you use the correct data, if you're using 9.81, I use it although 10, so you will get the 4 meter exactly. Yes, option C will be the answer. Okay, so I think this is okay. So here's the next question. Okay, in next question, in the figure shown below, air is contained in the pipe. Okay, this is pipe, and air is contained in this pipe, as it is mentioned in the question. Air is contained in the pipe and water in the manometer. Here we have water. Okay, and he is asking about the pressure at A. This is the point in the pipe. So what will be the pressure at A approximately? Okay, approximately what will be the pressure at A? Okay, so guys, here's the figure. So how to solve this one? So let us see. Anything else given to us? No. The pressure at A approximately. So generally, if we talk about the atmospheric pressure, because here air is given, this is air basically. So atmospheric pressure, can you tell me what will the atmospheric pressure? What will be the atmospheric pressure? Okay, let me check. Okay, this is the see. Okay, earlier question. Atmospheric pressure value. Can anyone tell me what is the atmospheric pressure value? Is it 101.3 into 10 raised power 3 Pascal? Is it okay or not? Atmospheric pressure. Fine. This is the basically atmospheric pressure that you can take here. So why I consider atmospheric pressure basically, because here we have air, also we have air here. Okay, the pressure that air will exerting on this water is what? Atmospheric pressure. So just equate this atmospheric pressure to the pressure formula. What is the pressure? That is nothing but rho g into h. Is it okay? And atmospheric pressure, let it be P ATM. This is 101.3 into 10 raised power 3 Pascal, that is Newton per meter square, equal to what? Rho into G. So what will be your value of rho G? Can you tell me? Rho G, that is density of what? Rho is the density of water and g is the gravitational acceleration. So definitely this will be coming to be 9.81 what kilonewton per cubic meter. So I'm writing it in 10 to the power 3 multiply. So it is coming to be Newton per cubic meter, and here h as it is. So in simple way we can calculate h from this equation, that is coming to be 10 to the power 3, 10 to the power 3 cancel out. So it is 10.1. Just take it 10. 9.81, let it be 10. So 101.3 divided by 10. So it is coming to be 10.1 meter of water. So approximately I consider here G 9.81, let it be 10. So this is my answer, 10.1. So let us see the closest option, 10.14, and this is 0.2 meter of water and 1.2 meter of water vacuum, and option D is the 4901 Pascal. Okay, option A will be the answer. Option A will be the answer. Fine, yes. Is it okay? So let's proceed further. So here's the next question, guys. So have a look on this one and let me know what will be the answer. So an isosceles triangular lamina of base, isosceles triangular lamina, base width 1 meter and height of that isosceles triangular lamina is 2 meter, is located in the water, which is placed in the water in vertical plane. Okay, its vertical axis is 1 meter below the free surface, its vertex is 1 meter below the free surface of the water. Okay, the position of the force acting on the lamina from the free water surface. So basically he is asking about the center of pressure. So let me draw the figure. So here we have a isosceles triangular lamina with base width 1 meter, fine, and its vertex from the free water surface is 1 meter below. This is given in the question. 1 meter below, and this height of triangular lamina which is placed in water is 2 meter. Okay, so suppose somewhat here let be CG, and let somewhat here will be your center of pressure. So distance of the CG of this lamina from the free water surface, let be y bar, and distance of the center of pressure from the free water surface, let be h bar. Fine, he is asking what will be the h bar. So you can see if we have a triangle like this one, you know very well, somewhat here let it be CG. So what will the distance from its base? If altitude or height of this triangle is small h, then definitely it will be h by 3 from the base and 2h by 3 from the apex. Okay, so from here to here, this distance from here to here, it will be 2 by 3 of h is nothing but 2. This is coming to be 4 by 3 meter. Fine. So just add 1 meter, you will get the y bar. Y bar will be 1 plus 4 by 3. So this is coming to be 7 by 3 meter. So I'm not solving it. I'm just putting it as it is. Now h bar, how to calculate h bar? H bar is your y bar plus Ig upon A into y bar. This we have the formula. Clear? So just sketch the value and let me know what will be the answer. So h bar equals to y bar is 7 by 3 plus Ig. What is Ig? Ig is a moment of inertia about the centroid. So moment of inertia about the centroid of this figure. Okay, and parallel to the free water surface, this is coming to be BH. Suppose this is your B. So Ig will be BH cube upon 36. BH cube upon 36. So let me solve this one. B is 1 meter, H is 2. So 2, 36. So 2 ones are 2, 2 18s are 36, 2 ones are 2, 2 9s are 18, 2 by 9. Ig is 2 by 9. I am putting it as it is 2 by 9. What is area? Area of this isosceles triangular lamina, half of base is 1 meter, height is 2. So this is coming to be 1 meter square. This is coming to be 1 meter square. This is coming to be 1 meter square. So this is 1 into y bar. that we already calculated 7 by 3. So just catch the value and let me know what is the answer. So 2 into 2 3 goes up, and here 9, 7, 3 3s are 9. So 7 by 3 plus 2 by 21. So guys, just solve it, take its LCM and let me know what is the answer. LCM is coming to be what? 21. So here we have 49 plus 2, it is coming to be 51 upon 21. 51 upon 21. So let us see option. Okay, so we have to solve this one. We have to solve this one, 51 upon 21. So just divide 51 by 21 and let me know what is the answer. So 21 to the 42. Fine. So 9 here. So decimal 0, 21 4 and 5 बड़ा हो जाएगा, 21 4 ठीक है. So 2.4 something. Let us see the option. 2.4 only. 2.4 is option A. This will be the answer. 2.42 will be the answer. 2.42 will be the answer. So have a look on this solution part, guys, and let me know, is it clear to all? Yes, option A will be the answer. Yes, very good, Ritesh. Option A. .42. Yes, fine, guys. So share as you can share this session so that most of students gets benefited. Although you know very well those students are keeping pace with us, so we already launched the module for the various PSU jobs. Okay, so in one module we are covering the most of PSU's examinations. Okay, so let me proceed further. So here's the next question. In this question, water level in a dam is 10 meter. So this is the height of water in at the upstream side of the dam. The total force acting on the vertical wall per meter length is total force. Okay, we have space here. So let me draw. Suppose here we have a dam like this one. So I am just drawing here a gravity type dam, concrete dam. So in this axis, so this here, suppose we have water. So this is kind of your upstream side and this is your downstream side. So what is the height of water? So this is given to us in the question, it is 10 meter. Fine. And he is asking what will be the total force acting on the vertical wall per meter length. So total force, that is the question basically. So what will be the total force? Okay, so this was the question. So just draw its pressure distribution diagram. So I'm drawing here. So it will be like this right angle triangle, linear variation of pressure. So here pressure will be what? What will the pressure at the base of the dam? Answer will be yes, rho g into h, pressure equal to rho g h, rho into g, rho g h. Pressure is nothing but rho g h. This rho g combinedly is what? Is the weight density or unit weight, whatever you want to call it, weight density or unit weight. So right now I am just denoting it with gamma, or you can write it small w, whatever you want to write, weight density or unit weight. So h, so I'm writing it gamma w, that is the unit weight of water, into h is nothing but 10 meter. Let me capital H. Fine. So where will be the total pressure will act? So we have this triangular formation pressure. So it will act at this point. This is kind of your centroid. So from base we have this one h by 3. From apex we have this one 2h by 3. Right? This we know very well. And this let capital P be your total pressure that is basically asked in the question. Total pressure force. This is per unit length of the dam. This is per unit length of the dam. In question, he clearly mentioned the total force acting on the vertical wall per meter length. So I am writing it total pressure force per meter length of the dam. Per meter length of the dam. Suppose here we consider it 1 meter. So only this portion, what will be the resultant pressure that we are writing here? Okay. So how can we write this P? Just calculate the area of this pressure diagram. Area is nothing but half of base into height. Is it okay? So it is coming to be, you can just check first of all the units. If you have any doubt, guys, you can check the units. This unit weight is having unit kilonewton or Newton per cubic meter, and this H will be in meter. Again, H will be in meter. So we are getting here kilonewton per meter. The unit of this total pressure force is in kilonewton per meter. Kilonewton is the unit of force. Meter, we are considering the unit length of the dam. So this is the force per meter length of the dam. So I'm just sketching here value half of gamma W. This you know very well. So this is coming to be 9.81 kilonewton me into H is 10 meter, again into 10. So 2 5s are 10. So just multiply 9.81 by 5 and again multiply it by 10, you will get the answer. So let me know what is the answer basically. Is it coming to be 490.5 kilonewton? So I just solve it now and it is coming to be 490.5 kilonewton. 49.5, no, 490.5. Option B will be the answer. Option B will be the answer. Fine. Yes. Those who's asking for this A के लिए कोई batch, yes, batch is currently is there. Module is launched offline, online, both classes are going on. ठीक है, offline and online. ठीक है, both classes are going on daily basis. So those students who are taking the classes, you can contact them, or I will share contact number. From there you can clear your query or doubt. Okay, Ishfaq already classes चल रहा है, already classes is there. Okay, so let's proceed with next question. So here's the next question. So guys, just read it first carefully. So a plate of rectangular shape having the dimensions of 0.4 into 0.6 meter. This is the dimension of the plate given to us, is immersed in the water with its longer side vertical. Longer side is what? 0.6 meter. This is vertical. That is, the plate initially is like this one. So right now formation, so that I can show here like this one. Okay, so don't mind the drawing. Basically I'm not so much good with the drawings. Okay, like this one. Okay, this we have plate. So longer axis or longer side is vertical. The total hydrostatic thrust on one side of the plate is estimated as this one. This is a hydrostatic force is given to us. Hydrostatic force is given to us on the one side of the plate. All other conditions remaining the same. That is, the dimension of the plates are same, and the vertical axis that it consider basically same, is turned through 90 degrees. Just turn it plate by 90 degrees. Just turn this plate by 90 degrees. Okay, turn this plate by 90 degrees such that its longer side remains vertical. Earlier longer side was vertical. After turning it through 90 degrees, again vertical side is vertical. That is, longer side is vertical basically. What would be the total force on the one face of the plate? So total force will not change. Simply total force will not change. Okay, so how total force will not change? So let me show here by figure. So suppose here we have the water surface, that will be free water surface, and in first case plate is like this one. Okay, plate is vertical. So let me try in another way. This is not showing the figure. The plate is vertical. So let me try vertical plate. So okay, let this one. This is vertical. Okay, and this longer side is 0.6 meter and shorter side is 0.4 meter. So the hydrostatic force that was acting on the plate was 18.3 kilonewton. It is mentioned in the question. Now he is saying if we rotate this plate by 90 degree, so just turn this plate by 90 degree. So what will happen if we are turning this plate by 90 degree? If we are turning this plate by 90 degree, so just okay. So let me check if I got something to show you. Yeah, this one. Okay, initially the plate is like this one, guys. If you can see this one, so initially the plate is like this one. Okay, the vertical side, this vertical face, or the longer side is vertical. This is 0.6 meter. Fine. This one is 0.4 meter. Now he's saying the hydrostatic force acting on this one 18.3 kilonewton. In second condition, he says just turn it by 90 degree. So I'm turning it by 90 degree. This was, I'm turning it by 90 degree. So what is happening after 90 degree turn, the plate looks like this one in 2D, like this one. So this value is what, 0.4 meter, and this value from here whole up to here is your 0.6 meter. So he's asking about the total hydrostatic pressure. So let this be your what, center of gravity. Here center of gravity. So you can see dimensions are same, no change in the dimension. Even there is no change in the center of gravity position. That is, if this is the, let it be y1 bar, that is the distance of the center of gravity in the case 1 from the free surface, and let this be the y2 bar, distance of the center of gravity in the second case. This distance from the free surface in both the cases are same. If the center of gravity distance from the free surface is same, definitely the hydrostatic force act on the plate will be same as per the Pascal's law. Okay, then answer will be the option B, 18.3. Option will be the option B. Here answer will be the option B, 18.3 kilonewton. So yes, Ishfaq, I will share number, don't worry, or even in the description you can just getting the contact info, so you can also contact there. If you are not getting from there, so I will share the number, don't worry. Okay, so I think let's proceed further. So here's the next question. So this is the next question, guys. So just have a look on the question and let me know what will be the answer. Okay, although this is looking some kind of, okay, we have to do a lot of calculation, but no, generally it is one line answer. This question is confirming to one line answer. Okay, this is a dam given to us. And this upstream side having the water, and this face is curved. Maybe there is a failure of the dam slope. So let it be earthen dam. What is happening here? The slope has been fell down. The height of the water retained by the dam is 20 meter. So this is 20 meter. Height of water retained by dam is 20 meter. The density of water is 1000 kg per cubic meter. Assuming as G value 9.81 meter per second square, the horizontal force acting on the dam per unit length is, what will be the horizontal force? So have a look on the figure and let me solve this one. Okay, so what we have to do? So horizontal force, so just sketch this water pressure distribution. What will be water pressure distribution? So definitely it will be like this one. Variation of water pressure will be like this one, linearly. Okay, maximum at the base of the dam. And minimum at the free surface. Of course, at the free surface the pressure will be 0. Okay, so the thing is that, but right now we have this curved surface. If it is like this one, then okay, that is in case of the gravity dam, then it was okay. But right now, okay, water pressure distribution diagram is okay, but how to calculate this horizontal pressure force, that is a separate thing that we have to use here, curved surfaces concept. So I am doing here. So this dam is given to us like this one, and height of water is 20 meter at the upstream. So if we are going to calculate the horizontal force, then we have to multiply the pressure by area. Which one area? Projected area. How to calculate the projected area? So projected area will be like this one. in the vertical plane. Projected area will be in the vertical plane. So whenever you are going to calculate the horizontal pressure force, what you have to do in the curved surfaces, so just write the pressure and multiply it by the projected area in the vertical plane. So what will the projected area? This from here to here is what? 20. This is 20, and from here to here this is 1. So if we write here force simply, then force will be what? Pressure into area. Pressure into area. Okay. So what will the pressure? So resultant pressure that you have to consider here, somewhat here will act your resultant pressure. So it is coming to be, so let me check, and okay, density of water is given to us, so I think this is solved. So it is coming to be rho g into h. Rho g into h. Fine. So rho g is nothing but 9.81 kilonewton per cubic meter. So h will be, so from, because this we have a rectangular formation, so 20, this is your 10 meter, this is your 10 meter, so multiply this by 10 into area. What will the area? 20 into 1 will be your area. So let me know, is this clear to you or not, guys? So 2 1s are 2, 2 8s are 16, 2 9s are 18, so this is coming to be 1962. So in kilonewton, this is the answer. So let me know, is it okay or not? Although this force is coming to be per meter length of the dam. Per meter length of the dam. This is a per meter length. Per meter length of dam. So let me know, is this clear to you guys? Is this question clear to all or not? So basically he is asking in Newton, so we frame the answer in kilonewton. So accordingly you can just sketch your answer. So what is our answer? In kilonewton. Fine. So just if we wrote here, okay, I'm doing here. If we wrote here 1.962, so 10 to the power 3 we divide, so we have to multiply it into, this is 10 to the power 6 becomes, because already kilo 10 to the power 3 in term of Newton, 1.962 into 10 to the power 6, 1.962 into 10 to the power 6. Yes, option C will be the answer. Option C will be the answer. Fine. So very simple question, just a little we consider the curved surface. Whenever we are considering the curved surface, then how to calculate the horizontal force on that curved surface? Just multiply that pressure into the projected area in vertical plane. If you are going to calculate the vertical force, that is the weight of the water we are considering on this curved part, so what we have to do, we are just multiplying the pressure by this horizontal area. Okay, or even you can consider the weight of the water on this column basically. Okay, sir, PPSC 157 plus general safe hai 8 departments. Yes, general will safe. If you belong to the general category, definitely you are in race. Don't worry. 1100 plus posts are there, so definitely you have a chance, no doubt. Okay, so just have a talk with your guys also, so friends also, so no one also, so that you can have idea what marks they are scoring. Okay, so 157 is a very good figure. So let's proceed further. So next question, a cylindrical gate is holding water on one side. This cylindrical gate, so this is holding water on this side, this one. In the figure below, the resultant vertical component. Right now he's asking about the vertical component. So I already told to you, whenever we are going to calculate the vertical component, So just catch the weight of water on this one. Just catch the weight of water on this one, or even you can just do what is the amount of water that is displaced by this formation, red formation. What is the amount of water that is displaced by this semicircle? We can calculate the amount of water. So if we are applying the displaced volume of water by unit weight of water or weight density of water, so what we are getting here? So kind of force. Okay, so we are just proceeding this with in standard way. So let us, so just have a look on the question and let me do the vertical force. So I'm writing here vertical force. Vertical force. So how can we write this vertical force? So I'm writing it weight of water displaced by the weight of water displaced by, so let's give name to them. So let be O, let be A, B, C, D. So A, B, C. Fine. Let be A, B, C. So weight of water displaced by A, B, C. So just calculate the weight of water displaced by the ABC and you will get here answer. So weight of water, so weight density is what? Weight per unit volume. So just multiply weight density, that is gamma, or you can just consider it small w, weight density, into volume. What type of volume? That is the volume of water displaced by the object. So definitely this will be equal to the this area of semicircle multiplied by 1 meter length. We are considering the unit length. Okay, so I'm just writing here rho g into v. V is the volume displaced by the object. Okay, so semicircle we have basically rho g, water is there, so this is coming to be rho is 1000, g is 9.81. So volume, so semicircle pi by 4 into, have a look on the question, pi by 4 into diameter is 2, pi by 4 into d square. So we have semicircle, so just make it half into length is 1 meter. Okay, just solve it guys and you will get the answer. Just solve it and you will get the answer. So let me do the calculation. Okay, this is coming to be 15409.5. So let me check, is there any option? Yes, this one. Option C will be the answer. Option C will be the answer. This is a weight per meter length. Option C will be the answer. Yes. So yes, Ritesh, your answer is okay. Yes. Rajdev, guys, please have a look on your answer. So answer is option C. So again, just check your calculation whether you did okay or not. So you just have a look on the calculation again, because calculations are very most important. If you make a mistake in the calculation, definitely you will go with the wrong answer, and that will also frame in the option. Okay, that is the biggest hurdle for us. Fine. So okay, here the next question for you guys. So what is the specific gravity of marble stone? He's asking about the specific gravity of the marble stone. What will be the specific gravity of the marble stone, which weighs 400 Newton in the air? Marble stone weighs 400 Newton in air and 200 Newton in water. 200 Newton in water. So can you tell me what will be the buoyant force? What will be the buoyant force? 400 Newton. 400 Newton is the weight of that marble stone. Let it be marble stone, and this is in air. Okay, if we talk about what is the weight of that marble stone in water, so it is 200 Newton. So I think 200 Newton is reduced, so buoyant force, simply we can write it 200 Newton. Generally this will be your buoyant force. Fine. So let me know right now what will be the specific gravity. So how can you calculate the specific gravity? That is the question basically. So I'm just waiting for your comments, guys. So anyone? No. So, okay. So let me solve this one. So let us consider this is your marble stone. Let me marble stone. Marble stone. So let its volume be Vm. M stand for marble stone. V is the volume. Fine. And let its density be or mass density be rho m. That is the density of marble stone or mass density of marble stone. Whatever you want to write. That we consider basically. Fine. So weight of marble stone in air that was given to us. It was 400 Newton. So how can we write weight of marble stone? Simply this weight of marble stone in air is nothing but weight density of marble stone multiplied by the volume of the marble stone. Volume of the marble stone is Vm. Density of the marble stone is rho m. So rho m into G into Vm will be your answer. Fine. This is nothing but 400, so I'm writing it 400 equal to density of marble stone into acceleration due to gravity value into volume of the marble stone in here. Equation 1. Okay. In second case, weight of the marble stone in water is given to us, which is equal to what? What will be the weight of the marble stone in water? So definitely there will be the buoyant force. We know very well. So this stone basically the weight will act in downward direction, the buoyant force will act in upward direction, buoyant force Fb. So how can you write this one? So just subtract the value. So buoyant force exerting by water. So what we are doing is mass density of marble stone minus mass density of water into G. Fine. And volume of marble stone as it is, because the volume of marble stone will be constant. It will displace the volume of water equal to volume of marble stone. That displaced volume of water is multiplied by what? Weight of water. So we are getting here the buoyant force. Fine. Is it okay? So I think this is okay. So this is given to us in the question. 200 equals to density or mass density of the marble stone minus density or mass density of the water into gravitational acceleration value into volume of the marble stone. So just dividing the equation 1 by equation 2, we will get, so 400 divided by 200 equals to what? This rho mg into Vm upon rho m minus rho W or water into G into Vm. So this Vm, G, Vm cancel out. So this is coming to be, have a look on this one. This density of marble stone to density of marble stone minus density of water equal to 2. So I cross multiply here. So density of marble stone equals to 2 times density of marble stone minus 2 times density of the water. So this is coming to be density of the marble stone to density of the water. This is coming to be what? 2. The specific gravity is 2. This is nothing but specific gravity. So specific gravity of the marble stone is 2. Specific gravity of the marble stone is 2. So I just waiting for your answer, guys. So specific gravity of the marble stone is 2. Is it okay? So I'm proceeding further. Okay, here's the next question, guys. So have a look on this one and let me know what is the answer. So in this question, a piece of wood of volume V, volume let be V given to in the question. Specific gravity is 0.87. Specific gravity of the wooden block is given to us, which is floating in the water, or it floats on the surface of a liquid whose specific gravity is given in the question. It is 1.31. Fine. The portion of the body which is submerged in the liquid will be portion of the body which is submerged in the liquid. That is the question basically. Fine. So generally have a look on this question. So I am going to for the next page for the solution of this one. Okay. So suppose I don't know the shape, so I consider a irregular shape wooden block like this one. This is a wooden block, irregular shape. So let's somewhat here is the water surface, and some portion is above water and some portion is below water. So its volume is given to us. Overall volume is V. This volume is V. Volume of wooden block is V given in the question. So portion of wooden block below the water surface let be V2. Portion of wooden block above water surface let be V1. Total volume is capital V. That is given in the question. Fine. So have a look on the question again. So specific gravity of the wooden block is 0.87 and it floats on the surface of the liquid having specific gravity 1.31. So if we wrote the weight of the wooden block, so what will be the weight of the wooden block? Weight of wooden block, so let it be capital W, and I am writing a subscript small w, that is weight of the wooden block. So definitely if we are talking about the weight, so it will be weight density into volume. So this is the density of the wood into acceleration due to gravity into what? Volume of the wood. Okay, this you know very well. Fine. And if we wrote buoyant force, because suppose weight is acting in this direction W, downward direction is your center of gravity point, and your buoyant force will act through this center of buoyancy point, let be FB. Okay. So what will be the buoyant force that we have to calculate now? So what will the buoyant force? So this immersed volume we consider V2. We just multiply this immersed volume with the, so here liquid is given to us whose specific gravity is given. Specific gravity is 1.31. Specific gravity is 1.31. So what we are doing? We are multiplying this immersed volume with the density of liquid into acceleration due to gravity value. So this is kind of your weight density of the liquid. Fine. So specific gravity is given. So how can we write this one, weight density of the liquid? So this weight density of the liquid will be 1.31 times the density of the water into G into V2. This will be the buoyant force. Fine. This will be the buoyant force. So definitely if the wooden block is floating, so we are just considering here equilibrium conditions. So this weight of the wooden block should be equal to this buoyant force. Weight of the wooden block is what? Density of the wooden block into G into volume of the wooden block, equate it 1.31 into density of the water into G into V2. So G will cancel out. Is it okay? And density of the wooden block, specific gravity of the wooden block is given to us. So I am just replacing this one. I just eliminate one step. So this is coming to be 0.87 into density of water. Fine. So density of water will cancel out each other. So from here, just calculate the V2. What will be the V2? So V2 is coming to be 0.87 upon 1.31. 0.87 upon 1.31 times of volume of the wooden block. So have a look on this one and let me know what will the answer. So just solve that one, guys. So 0.87 upon 1.31. So it is coming to be 0.664 times of the volume of the wooden block. This is the basically answer. So yes, option B will be the answer. Have a look on the solution part, guys. 0.664, yes, good. Rajdev Yadav, yes, option B. Option B will be the answer. Yes, good, guys. So keep practicing and solving the question along with me. Definitely it will boost your speed and accuracy also. So let's proceed to the next question. So in next question, the submerged body will be in stable equilibrium. When will be the submerged body in the stable equilibrium? Very simple question. If the center of buoyancy. So whenever submerged bodies are there or floating bodies are there, two things we have. One is floating body and another one is the submerged body. So floating body, FM fluid mechanics. So floating body, whether in stable or unstable or neutral equilibrium, meta center will decide that one. For stability of floating body, meta center playing an important role. And if we talk about the submerged body, then center of buoyancy is playing an important role. So generally meta center is above the center of gravity, stable equilibrium. The center of buoyancy is above the center of gravity, stable equilibrium. Meta center is below the center of gravity, it is unstable. Basically same thing here, center of buoyancy lying below the center of gravity, unstable. So he's asking about the stable equilibrium. Definitely the center of buoyancy is above the center of gravity. Fine. Is below the center of gravity. Rajdev, please have a look on the question again. Yes, Abhimanyu. Option D will be the answer. Yes, good. Abhimanyu, your answer is okay, but Rajdev, have a look on the question again, guys. Okay. So I give you a trick here. Whenever we are talking about the floating body, meta center will decide whether the body will be in stable equilibrium, unstable or neutral. Whenever we are going with the submerged bodies, then we are dealing with the center of buoyancy. If it is above the center of gravity, then we have the stable equilibrium. If it is on the center of gravity, then neutral equilibrium we have. If it is lying below the center of gravity, then we have the unstable. Fine. Okay, so let's proceed further. Another theoretical question. Uniform flow occurs when? Uniform flow occurs when? Uniform flow occurs when? When uniform flow takes place, basically. This is the question. So uniform flow, first statement, at every point the velocity vector is identical in magnitude and direction at any given instance. So whenever we are talking about uniform flow, that is flow properties remains same with respect to space. Flow properties is same रहेंगे. These are the same or constant with respect to space. And if we talk about the steady flow, ठीक है, steady flow is for the uniform flow. Uniform flow, the properties remains the same. For steady flow, the properties remain same with respect to time. That is invariable with respect to time. So have a look on this one. The flow is steady, no. Uniform, he is asking about the uniform. How option B will be the answer? Discharge through a pipe is constant. Conditions do not change with any, ठीक है, at any time. So only option A will be the answer. Okay, at every point the velocity vector is identical in magnitude and direction with respect to the space, that is at any instance. At any instance. Or in short, you can just have a look on this one. If we do the partial derivative of this velocity vector with respect to the space, so this is constant, so constant derivative we are getting it 0. Okay, at a given instant of time, basically, let me t. Fine. So here's the next question. So in next question, flow field is given to us. A two-dimensional flow field is defined as V equals to x I cap minus y j cap. This is the velocity vector given to us. The equation of the streamline passing through the point 1, 2 is. So let me know equation of streamline. Equation of streamline. So I'm writing from here equation of streamline. Okay. So what will be the equation of streamline? So anyone? Equation of streamline. Okay. So let me write here equation of streamline. So it is coming to be dx upon u equals to dy upon v. So u and v are basically velocity components in x and y direction. Here u equal to, in this question here u equals to x and v equals to minus of y. You can check xi positive minus yj. ठीक है, unit vector I and j. So just put the values. So I'm writing it here. Dx upon x equals to minus of dy upon y, that we are getting here with the help of the streamline equation. So just for the time being now, integrating on both sides. Integrating on both sides we get. Okay, just do the integration. So dx upon x equal to minus of dy upon y. So it is coming to be log x equal to what? Minus of log y plus constant of integration log c. So this minus term on left hand side becomes positive. So equal to log c. So log m into n is nothing but log m plus log n. So log will cancel out each other. So no need to cancel, although it is understood. So we are getting here xy equal to c. We are getting this value xy equal to c. Okay, on solving. So in question, he said the equation of streamline passing through the point 1, 2. X coordinate is 1, y value is 2. So put here x equal to 1, y equal to 2. So 1 into 2 is nothing but c equal to 2. So just sketch the value xy equal to c, that is 2, or xy minus 2 equal to 0. That will be the answer. That will be the answer. So here equation of streamline will be x y minus 2 equal to 0. X y minus 2 equal to 0. Is it okay? Option C. Yes, fine. So I think let's proceed further. Here's the next question. So velocity potential function in a two-dimensional flow field. Velocity potential function in a two-dimensional flow field is given by this one. So the magnitude of velocity at point this is. Okay, so this velocity potential function is given to us. What its value? So x square minus y square. So x square minus y square. So x component. If we wrote here x component, that is u equals to minus curly phi upon curly x. So it is coming to be what? Minus 2x. Is it okay? Fine. So y component. What will be the y component? Y component, that is v equals to minus curly phi upon curly y. It is coming to be minus of y square derivative with respect to y, 2y. So again minus of minus plus of 2y. In question he said it is passing from point 1, 1. So 1, 1. So at 1, 1, so u equal to minus of 2 into 1, that is 2 minus of 2 unit, and v equal to 2 into 1, so plus of 2 unit. So resultant will be square root of u square plus v square. So this is coming to be minus 2 ka square plus 2 ka square. So 4 8, it is coming to be 2 root 2 unit. It is coming to be 2 root 2 unit. Answer is option C. Yes, very good. Option C will be the answer. Very good. Clear? So such type of questions are extremely important, guys, in which either you have to check whether the equation given to us in the option are satisfying the Laplace equation or streamline equation, or you have to just go with the streamline equation. You have to tell the streamline equation with respect to the given velocity potential function at a particular given points. Okay, so such type of questions are extremely important. So here's the next question. So a fluid jet is discharging from 100 nozzle and the vena contracta formed has a diameter of 90 Fine. So generally, if we consider, suppose here we have a tank. This is a way of understanding the thing. Suppose here is the opening. Okay, although in question he is said basically the nozzle. Okay, so this diameter is given to us 100. So when fluid is coming from there, there is a particular distance from the opening, that is vena contracta, least cross sectional area of jet we get vena contracta. So here diameter is 90 okay, here is 100 so just we have to write here the first coefficient of contraction, but he's asking about the coefficient of discharge. Okay, we can calculate this one also, so no issue. So first of all, let us see what will be the coefficient of contraction. So coefficient of contraction, how will you write? So area at the vena contracta. So area at vena contracta divided by area of orifice. Fine. Or you can say it at nozzle exit. Because nozzle given in the question, nozzle exit. So how can you write? So it will be pi by 4 into d ka square, 90 ka square, in denominator pi by 4 into 100 ka square. So 9 square, what? 90 into 90, we can write it directly, 90 into 90, and in denominator 100 into 100. Fine. So it is coming to be 81 by 100, so 0.81. 0.81 is your CC. CC we got here 0.81, and in question CV is given, I think so, yes, coefficient of velocity is 0.98. He is asking about the coefficient of discharge. So coefficient of discharge equal to what? CC into CV. Fine. So just multiply the CC 0.81, CV given to us 0.98. So let me know the answer. So what is the answer, guys? 0.7938. 0.7938. Okay, then option B is your answer. Option B is the answer. Very good. So here's the next question. चलिए सॉल्व कीजिए. Okay, so just solve it, guys. So water flows through a vertical contraction from a pipe of diameter d to another diameter d by 2, that is we have a varying cross section pipe. So contraction mentioned in the question, d by 2. Inlet velocity at inlet to contraction is 2 meter per second, and pressure at inlet is this one. If the height of contraction measures 2 meter, the pressure at the exit of contraction will be. So just have a look on the question. So I'm giving you 30 seconds. Just read the question first carefully. Okay, so let's solve this question. So first of all, let me draw here the figure. So here we have the contracted formation like that one. So let this be the inlet. So I'm representing this, let it be the inlet. So velocity at inlet V, let be V1, 2 meter per second, and pressure at the inlet. So let me check now. Pressure at the inlet was 200 kilonewton per meter square. Pressure at the inlet was 200 kilonewton per meter square, and he said this distance of contraction from the inlet was 2 meter. Okay, so I am considering it that amount because I have to apply here the Bernoulli's equation at this section. Let be 1 inlet and this contraction point 2. So here diameter is d by 2 and at inlet, okay, inlet the pipe diameter is d. So here d diameter given to us. So just apply the Bernoulli's equation and let me know what it is coming to be. So kind of P1 upon rho g plus V1 square upon 2g plus Z1 equals to P2 upon rho g plus V2 square upon 2g plus Z2. Now pay attention, this section 1 that is inlet, this we consider at datum. So Z1 is 0 basically. Fine, Z1 is 0. Is it okay? Now what we are doing, the amount of liquid basically passing to the section 1 definitely that will pass to the section 2 also. So we are applying here continuity equation. So kind of A1 V1 equals to A2 V2. So what is the A1? A1 is nothing but pi by 4 into d square into V1. V1 is given in the question. This is 2 equal to A2 pi by 4 into d place we have d by 2 ka square into V2 as it is. So pi by 4 will cancel out. D square will also be cancel out. So this is coming to be, so have a look, V2 is coming to be, so 4 to the 8. Is it okay or not? 8 meter per second. This we are getting here. Velocity is 8 meter per second that we got here. Okay, V2. Fine. So just he's asking about the what is the pressure at the exit of the contraction. He's asking about the P2. So I think just put here P1 is what? P1 is 200. So P1 is 200. So P1 is 200. Fine. Rho g, I am leaving it as it is. V1. V1 is what? Given in the question 2 meter per second. So 2 ka square. Fine. P2 that we have to calculate. V2 we just calculate now 8. So 8 ka square upon 2g and Z2 is 2 meter. So this is 2 meter basically. So guys just solve this one and let me know what is the P2. What is the P2? What is the P2? Even you can just thoroughly what? Okay, just take the G value as it is and let me know what is the answer. So just solve this one and let me know what is the answer. So this thing, only this thing you have to solve and you will get the answer. 172 nearly. 192. Abhimanyu saying 192 and another one is 172. So okay. So anyone? So let me know what will be the answer. Point. Sorry, option A or option D. That's the question basically. I just seeking rest of guys answer. So this is coming to be what? So this is coming to be 176 like that one. So this is coming to be option D. Option D will be the answer. Have a look on the calculation part. So you will get the option D is the answer. Fine. Option D will be the answer, guys. Okay, he is asking, sir, 162. Let's see. ओके ये जो बच्चे पीपीएससी जेई वाले हैं, दो स्टूडेंट्स हु आस्किंग देयर डाउट्स रिगार्डिंग द कट ऑफ फॉर पीपीएससी जेई, so that I will tell you separately, guys. Okay, although I clearly mention, if you are getting 150 plus, okay, 150 plus, and suppose you have some quota like your OBC, SC, ST, definitely you are in race. Definitely you are in race. ठीक है, although 300 marks total marks were there. Fine. Okay, so let's proceed with the next question. So we are now having less time, but questions are more. For an irrotational motion, the fluid element does not undergo any shear. The fluid particle does not undergo a circular motion. The circulation around any path is zero, or option D. What will be the answer, guys? What will be the answer, guys? So for an irrotational motion, this we know very well, the circulation around any path is zero. Circulation around any path is zero. Option C will be the answer. ठीक है, circulation per unit area is your vorticity. Circulation per unit area is vorticity. Circulation per unit area is vorticity, that you know very well. Circulation per unit area is the vorticity, and if we wrote this vorticity, half of vorticity is nothing but rotation. Half of vorticity is nothing but rotation. Okay, the circulation around any path is zero, that is the flow is an irrotational flow. Okay, next question. In case of transmission of hydraulic power by a pipeline to turbine in a hydroelectric power station, the maximum power transmission efficiency through the pipeline is. So in this case we know very well, this head loss due to friction, if we want the maximum efficiency, it is nothing but 1/3 of the maximum available head. Fine. So efficiency, maximum efficiency, that is the Eta Max maximum efficiency, Eta Max is what? How can you calculate this one? So this is nothing but your this available head, net available head, which is equal to H minus HF upon H into 100% की term, right? So in place of HF, I am writing it as H by 3 to H. So it is coming to be 2H upon 3H. So cancel out 2 by 3 is coming to be 0.6667. So it is coming to be 66.7%. Maximum efficiency is 66.7%. So 66.7, let be 67%. Simply. No need to solve even this type of question. You know very well what would be the answer. This I wrote because earlier in the previous class we solved a question where we have to calculate the head loss due to friction. So we use the Darcy-Weisbach formula. And oil flows through a pipe at a velocity of 1 meter per second. Oil flows through a pipe of velocity of 1 meter per second. The pipe is 45 meter long and has 150 mm diameter. What is the head loss due to friction? Head loss due to friction, Darcy-Weisbach formula, HF equal to 4 FL V square upon 2 GD. Okay, even if you are writing with respect to friction factor, then FL V square upon 2 GD will be the head loss due to friction formula. Clear? That will be the formula. Is it okay? So just apply the formula and let me know what will be the answer. So here's the formula. So let me check. Yes, we have a space. Head loss due to friction is 4FLV square upon 2GD. Now, first of all, we have to know whether the flow is laminar or turbulent. Why we have to know? Because we have to calculate the coefficient of friction. So let us check Reynolds number. It is nothing but rho Vd upon mu. Rho is the density. Density is given to us 869. Velocity of flow is 1 meter per second. Into dia of pipe is what? That was the given in the question, I think. So yes, 150 mm. so kind of 0.15 meter, ठीक है, upon dynamic viscosity is what in kg meter per second, kg per meter second, that is given to us basically. So okay, so we can use it like this one, 0.0814. So let me know what is the Reynolds number. What is the Reynolds number, guys? What is the Reynolds number? Reynolds number here coming to be, so let me solve this one. 869 into 1 into 0.15 divided by 0.0814, it is coming to be 1601.4, which is less than 2000. Hence the flow is laminar. Flow is laminar. Flow is laminar. And we know very well, if we have the laminar flow, then coefficient of friction and the Reynolds number are related to each other. How? This coefficient of friction F equals to 16 upon Re. 16 upon Re. Fine. 16 upon Re. Then let us put this 4 F upon what? So I'm just putting the values directly. Let us see what will the answer here. 4 into, in place of F I'm writing it 16 upon Re upon 2 into G is 9.81 into V square. Velocity is I think 2 or 1. Let me check. Velocity is 1, not 2. Velocity is 1. So here velocity given to us is 1. So 1 into 1, only 1. So I'm just writing it directly 1. So लिख देता हूँ, V square upon D, diameter is 0.15. So solve this one and let me know what is the answer. Okay, so it is it coming to be 0.6 like that one? 0.6 in term of meter. So I solved it now. So it is coming to be option A. Option A is the answer. Just have a look. Is it okay or not? So have a look on the solution part. So is it okay, guys? Okay, so let's proceed further. Here's the next question. Which one of the following statement is approximate for the free surface? The hydraulic gradient line HGL, which is equal to what? Your pressure head P upon rho G plus your datum head Z. This is your hydraulic gradient line height, okay, from the datum, and energy gradient line, that is EGL. So in this piezometric head, we have to just add the kinetic head or velocity head V square upon 2G. These lines are always parallel to each other, separated by the kinetic head. So parallel to each other, but they are the different line. Yes, option A will be the answer. Simply option A will be the answer. Fine. The hydraulic gradient line and energy gradient line are parallel to each other, but they are separated by the kinetic head or velocity head. Clear? So here's the next question. 3 identical pipes of length L, diameter D, and friction factor F are connected in parallel between the two reservoirs. Okay, what is the size of the pipe of length L and the same friction factor F equivalent to the above pipe? So this is the question basically. So suppose here is a tank number 1 or reservoir number 1, here is a tank number 2 or reservoir number 2. So 3 pipes are connected like this one. So don't mind the drawing, guys. Here we have the pipe number 1, pipe number 2, pipe number 3 having length L. So discharge in each pipe, although discharge will be same. So discharge in first pipe equal to discharge in second pipe equal to discharge in third pipe equal to, let be Q. Fine. So in the question, as in the question, he mentioned 3 identical pipes having length, तीनों का length same, having same length of each pipe, diameter is same, friction factor is same, definitely discharge will also be the same. So if we are replacing these three pipes by a single pipe, that is equivalent pipe, now having diameter what, length will be same, friction factor will be same as that of the previous three pipes, as that of the previous three pipes. So he is asking what is the size of the pipe. He is asking basically what should be the diameter of this pipe. Let me capital D. What should be the diameter of this pipe? This is the question. So in the previous class I already this derived relation. So right now I'm directly writing this one, head loss due to friction. So HF equal to head loss due to friction. This is coming to be 32 into friction factor into length of pipe divided by pi square G into what? Your square of discharge into small d raised power 5. That is, small d is the dia of each pipe. This is given in the question basically, dia of each pipe which are connected to the two reservoir number 1, reservoir number 2, and the three pipes are parallel to each other having the same length, same friction factor. Okay, so if we consider the head loss due to friction in this single pipe, that is equivalent pipe, so I am just writing it with another color, which is equal to 32 times friction factor is same, length of pipe same, pi square same, G will be same. Only difference is that here discharge will be 3 times of the discharge in this parallel pipe system. So in place of Q, just wrote here 3Q square upon D equivalent. Let dia be the capital D. Okay, so let me write here capital D. Capital D raised power 5. Fine. So in question he mentioned the what is the size of pipe length and the same friction factor equivalent to the above pipe. So what we are doing here, we are just equating the left hand side equal to right hand side, because left hand side same, then definitely right hand side will also be same. So 32 FL upon pi G square will cancel out. So Q square upon small d raised power 5 equal to 9Q square upon capital D raised power 5. Q square will cancel out. So this is coming to be capital D raised power 5 equals to 9 times small d raised power 5. So capital D equals to 9 raised power 1 by 5 into small d. So let us check, is there any option? So guys, just solve this one. This is multiplication. 9 raised power 1 by 5. So 9 raised power 155. Okay, this is coming to be 1.55. So this equivalent diameter will be 1.55 times of the diameter of the pipe which are connected in parallel. So answer will be option A. Option A is your answer. Option A is your answer. Okay, Abhishek. So just go with the next question. So guys, just boost up your speed. Boost up your speed. So I think this will be clear to all. So let me know. Is this clear? Okay, so I think this will be clear. So let's proceed to the next question. So here the next question in this is asking the velocity and the corresponding flow areas. The velocities and the corresponding flow areas of the branches labeled as 1, 2, 3, 4 and 5 for a pipe system shown in the figure below. Okay, so here is the system given to us. This is the pipe number 1, pipe number 1, pipe number 2, pipe number 3, pipe number 4 and pipe number 5. So pipe level 1, 2, 3, 4, 5, velocity is given in the table, area is given in the table. So you can see here the V3, that is the corresponding to pipe number 3, velocity is not given, so he may ask the velocity. Okay, and you can see here velocity corresponding to pipe number 5 is also unknown, so he may ask or she may ask the velocity in the pipe number 5. So let us see what is basically demand in the question. The velocity V5 would be, he's asking about the velocity. So V5, just you can see here. So just consider this junction, this one junction. So pipe number 1, pipe number 5, pipe number 4. So here this flow and this flow ultimately going in this direction, like that one. So we can apply here continuity equation. That is how A1 V1 plus A5 V5 should be equal to what? A4 V4. Is it okay or not? Let me know this one. A1 V1 plus A5 V5 equal to A4 V4. A4 V4. ठीक है, applying continuity equation on this junction. So A1 V1 plus A5 V5 equal to A4 V4, that I wrote basically. So what is the A1? A1 is 4, V1 is 5. A1 is 4, V1 is 5 plus what is A5? A5 is 8 and V5 we have to calculate. So 8 into V5 as it is. What is A4 into V4? A4 is 10, V4 is 4. 10 into 4. So you can see guys, 20 plus 8 V5 equal to 40. So 0, sorry. So here we can write it 8 times V5 equals to 20. So V5 equals to 20 by 8. So it is coming to be 4 to the 8, 4 5 the 20. This is coming to be 2.5 meter per second. This will be the answer. 2.5 meter per second. Option A will be the answer. Fine. He may ask the V3. Fine. Okay, so how to calculate the powers like 1/5 without the calci in the exam? So guys, you just have to go with the Vedic Ganit. Okay, Vedic Mathematics. So just have a look your mathematics classes. Just follow the tricks as given by the Tyagi sir. So this part I am leaving basically as the question is coming. So how to calculate this one? So simple answer. Just use the tricks. Just remember the few things. How to calculate the cube root or 1/4 value, 1/5 value, like that one. Okay. So is it okay, guys? So I think this is okay. So let's proceed further. So next question, Weber number is the ratio of square root of inertia to. Weber number is the ratio of what to what. Weber number is the ratio of what to what. Okay, this is the basically boosting question for you. Boosting question for you. How? So I'm giving you a trick. Trick is this one. Few men can drive gypsy. Although spelling of gypsy is somewhat different, but for the making concept, just take it like this one. So we know very well F is standing for the fraud number. F is the fraud number, and this fraud number is the ratio of inertia force. G stands for gravity. Fraud number is the ratio of square root of inertia force to the gravity force. How to remember? Even how I remember. E stands for your Euler number. So it is the ratio of basically what? Ratio of inertia force to pressure force, P for pressure, square root. Okay, and W stand for Weber number. It is the ratio of inertia force to surface tension force, S for surface tension. So he asked here the Weber number. Answer will be option A. Okay, and if we talk about the Mach number is the ratio of square root of inertia force to the elastic force, inertia force to the elastic force. Okay, so although Reynolds number you know very well, it is the ratio of inertia force to the viscous force. Inertia force to the viscous force. How to remember? Even how I remember, few men can drive gypsy. Although spelling of gypsy is somewhat different, so this is the things. So you can easily remember the ratios of the forces. In next question, the time period of a simple pendulum depends upon its effective length. That is, the capital L is the effective length of the pendulum, and local acceleration due to gravity is the G. What is the number of the dimensionless parameters involved? Number of the dimensionless parameters involved. So I'm just doing here. So time period, we have this formula. So 2 pi root L upon G. That we have formula, time period. Okay, so even you can just write here, this time period of pendulum is the function of this length of pendulum into length of pendulum and this acceleration due to gravity value. And if we talk about the overall variables, so overall will be your time period, your length of pendulum, and this acceleration due to gravity. So number of variable involves, so total number of variables. So total number of variables involved. So you can just count 1 2 3 1 2 3, answer is 3. 1 2 3, answer is 3. Total number of the variable involves, let it be your what? Small n. Small n, I am denoting it the number of variable involved. So number of fundamental dimensions, number of fundamental dimensions. Okay, so here time period is in seconds, so time only t, time period second में होगा, time t, length of pendulum will be capital L. Okay, and G, this is your acceleration due to gravity. So LT minus 2, only 2 fundamental dimension LT. So here M equal to 2. So number of dimensionless parameters. So answer is N minus M, that is 3 minus 2. Answer will be option B. Answer will be option B. ओके सर एडमिट कार्ड कब आएगा शर्मा सर 20 को पेपर होगा या पोस्टपोन होगा सर जेई की बात कर रहा हूँ जेई सिविल में हाइड्रोलॉजी नहीं पढ़ानी जेई सिविल में हाइड्रोलॉजी हम पढ़ा चुके हैं हाइड्रोलॉजी रुचिन सर पढ़ा चुके हैं ठीक है of course hydrology पढ़ा चुके हैं all the classes are there so if you have doubts so daily we are having the doubt sessions okay tomorrow I will take class for especially for the JK aspirants so don't worry don't get panics so if you have doubts so we can solve there fine so here's the next question okay so in any way you can remember the tricks guys so no issue if I am telling you a tricks and you have already a trick so keep that in your brain okay don't mix the things that will be not helpful for you okay admit card will be there don't go with the admit card when it will comes so just look your preparation just know your preparation if you are up to the mark whenever admit card will release it will not affect you simply so I think so in this question you will give me answer so what will the answer Reynolds number is the ratio of what ratio of inertia force to viscous force है कि नहीं A4 simply I already told you Froude number is the square root of the inertia force to the gravity force 3 so B3 and this Weber number is the ratio of the inertia force to the what surface tension force so C2 बचा D1 so 4321 option B will be the answer option B will be the answer B yes एडमिट कार्ड विल बी देयर मोटिवेशन डाउन हो रही है मोटिवेशन डाउन नहीं होगी मोटिवेशन के लिए लेक्चर देंगे डोंट वरी घबराओ नहीं मोटिवेशन लेवल ऊपर बढ़ जाएगा ठीक है जिंदगी में मोटिवेशन ही सब कुछ है मोटिवेशन नीचे गिर गया सब कुछ नीचे गिर गया कुछ भी काम का नहीं रहा ठीक है ओके मोटिवेशन बढ़ाएंगे घबराइए नहीं मोटिवेशन सेशन विल बी देयर सो फर्स्ट ऑफ ऑल जस्ट चेक योर प्रेपरेशन so for the JK aspirants so there will be some few sessions अभी हम कंटिन्यू रखेंगे घबराओ नहीं डोंट वरी ओके सो दिस इज all about today's session guys so I hope you enjoyed this session a lot if you have any doubt you can ask me मजा आ रहा है सर बस क्वेश्चन कराओ बहुत सारे हाँ क्वेश्चन कराएंगे देखो we have to keep limits okay although I already told to you guys the module has already been launched if you have any query regarding the module in one module we are covering the so many PSU's examinations honestly speaking and the things that you got here is the clearing of your concept and along with the question that will really boost your knowledge and definitely you will crack the exam our main purpose is to crack the exam okay HAL में numerical level कैसे रखें same that I am taking here एटी नंबर आ रहे हैं देखो तुम्हें जहां पे भी कोई सा भी मॉक तुम्हें मिलता है जस्ट डू इट लगाइए इसे ठीक है जस्ट चेक योर प्रेपरेशन लेवल सो आई थिंक वी हैव टू एंड दिस सेशन हियर गाइस सो थैंक यू वेरी मच गाइस फॉर बीइंग with me in this session and just do one thing whenever class is there so share it as much as you can do so that most of students gets benefited okay if you have any suggestion you want to give any suggestion so you can just write your suggestion in the chat box comment box definitely we will do work on that one okay सर एग्जाम पोस्टपोन होगा क्या ओके पोस्टपोन की बात नहीं करेंगे ठीक है, पोस्टपोन हम चाहेंगे नहीं एग्जाम पोस्टपोन हो। Okay guys, so all the best and keep preparing with the Yourpedia Education. So I am ending this session here. If you have any doubt, so you can ask. I'm just waiting for 1 or 2 minutes. So one thing is that, so don't use rough language. So it is not suits for you guys. You are educated people, so why you are using this statement? बहुत बुरा लगा ये पढ़ के मुझे, ऑनेस्टली स्पीकिंग बहुत बुरा लगा। ठीक है, जो भी हो ऐसा नहीं बोलना है किसी को भी। ठीक है, सो ऑल द बेस्ट एंड गुड नाइट गाइस एंड कीप प्रिपेयरिंग विद द योरपीडिया एजुकेशन।